Some people ask me, what is this channel about? What do I propose for gravity, for electricity, magnetism, etc., right? And I have a series of 5 videos, which are at the top there of this channel, and also my other channel, bgaede. And it's called Introduction to the Rope Hypothesis. So those people who want to get an introduction of what we propose here in exchange to what they propose out there, the establishment, other dissidents, etc. This is what we propose. You can get your learning curve very quite steep here. Get a very quick introduction to each one of the subjects: light, electricity, gravity, etc. Okay, so and they're short. They're anywhere from, I think, 3 to 6 minutes, all of them. So if you just want to get a snapshot and get an idea of what the channel is about, that's where you have to go. Some people have asked me, well, what's your theory? And that's where you can get, in general terms, an overview. And then, you can work further by asking questions, looking at some of the other videos. But that's a good place to start. What do we propose? Well, I'm just going to go quickly over this, and I'm going to say that what I'm proposing is that physics, above all, physics is kid stuff. Anyone can understand physics. And I'm not talking about someone who went to college or even to high school. I'm talking about anyone who is 6 years old, 7 years old, 8 years old can understand physics. Okay? And people say, Bill, you're crazy. We cannot understand the universe. We cannot understand how some of these things work. And you're saying that a 6-year-old, a 7-year-old, an 8-year-old can understand this? Normal one, right? Not a mathematical physicist, but a 6-year-old, yeah, can understand it quite easily. And you might say, Bill, you're crazy. What are you talking about? And yeah, because physics is really for kids, and it doesn't require that you really know any math, that you run any experiments. The issue is understanding. Okay, and here's an example. Sometimes I put this example up here. Here's an example. Okay, look at this. Okay, someone asks you, how did the window break? And I think anyone who sees that right there in front of you, you say, well, the window broke because a brick went through it. Someone threw a brick through the window, through the glass. Very straightforward, simple, Did I ask you what was the energy, the mass, what speed, what was the force? I didn't ask you any of that. I said, how did the window break? That's what I want to know. That's, you broke my window. I want to know how it broke. And you say, well, I threw a brick through the window. That's how anyone would explain that. Very straightforward, okay? Now, someone asks here, how did the pulley come up? Or, how did the box come up? And you say, well, let me get rid of this in here. I tied it around a rope, the rope around a pulley, and I pulled on the rope. Someone pulled on the rope, and that's how the box went up. So if you want to know what caused the box to go up, you just look at this and say, well, I think everybody would answer the same thing. Say, the box went up because someone pulled on a rope and the box went up. That's it. Very simple. 6-year-old, 7-year-old, 8-year-old for sure can tell you, what he's staring at there. That's all we're asking. We're not asking how much did the box weigh, did you use so much force, was there so much energy involved on the rope, etc. None of that. We're just asking, how did the box come up? Okay, very straightforward stuff. And again, if you're going to answer questions of mechanisms of how something happened, there you have very simple stuff that even babies almost, I'm not going to go as far as babies, but certainly a 7-year-old and 8-year-old can tell you how something happened. Okay, and here's another example. Okay, here the spoon falls to the floor. Okay, now you say, well, how did the spoon fall to the floor? And now people go nuts. They go bananas. They go crazy. They say, I have no idea how the spoon fell to the floor. And, there is really no difference between what you're staring at there and what you just saw, okay? Let's put them all 3 together, see if we can find out if there's any difference here, okay? Here you have the 3, to compare. You've got a brick going through a window, you have the pulley pulling up the box, and you have the spoon falling to the floor. If I ask you how did the box come up, you have an answer. If I ask you how did the window break, you have an answer. Now you're saying you don't know how the spoon fell to the floor. Why it always falls to the floor? Why didn't it fall to the sky? And the only difference here between these 3 scenarios is that you cannot see the object that is in contact with the spoon. That is the only difference. Other than that, everything else should be straightforward. And so the issue here is that if we can make the invisible objects that Mother Nature uses to create that magic of the spoon falling down without apparently anything coming in contact with it, if we can make the objects that are causing that visible, maybe it would be like the other 2. There wouldn't be any difference. Okay, people would say, "Oh, that's how easy it was." an 8-year-old would be able to answer the question. And it turns out here we are 3,000 years after, the Greeks and other people started looking at these things, and not a single mathematician, a single scientist, so-called scientist on Earth, can answer that question. How did the spoon fall to the floor? And it's very simple. Here we have a pencil. I always use the pencil, okay? And you let go of it and it falls to the floor. And you say, what came in contact with the pencil? Okay, it just falls by magic, always to the floor. Now, in the case of the pulley, in the case of the brick going through the window, you can answer, but you can't answer the question, which is the same thing, essentially. Okay, it's the same type of mystery. The only difference is that you cannot see what is causing the spoon to fall to the ground. That's the only difference. So what we do here is, we do things with objects. We try to visualize, and we try to visualize the objects that are causing especially the effects that we cannot answer. Those, you can call them invisible, intangible objects that cause these magical phenomena, okay, that we cannot answer today, or the mathematicians cannot answer today. And what's the difference? Well, the big difference, it comes down to this, and it's got to do with the definition. Mathematical physics essentially works with two definitions, okay, of what a thing is, what an object is, what a mediator is. And there you have them. The first one is, and both of these are taken out of the Wikipedia. The first one is that which you can see or touch. Okay, so everybody thinks that an object is that which you can see or touch. That's what it is in everyday language and everyday notions that we have. And so that people carry those notions, those definitions into physics and say, well, it's that which you can see or touch. And the mathematicians essentially use these two definitions. And that's why they insist on experiments, because they can see and touch something in the lab. What they cannot see or touch are the invisible, intangible objects, things that are causing some of these effects, such as gravity. Okay? The other one is object is a collection of matter. Well, those are irrational definitions, because a chair is, a collection of atoms, but that's not, you don't think of every object that you look at as a collection of particles or units or whatever. You see Sylvester the cat on TV, right? And that's a cartoon. And so that's an object, right? A thing that you're seeing there, and you say it's a collection of matter. Is that what Sylvester is? No, a cat, any cat, the word cat is not a collection of matter. That's not what an elephant is. That's not what a table is. That's not what a chair is. That's not the notion that comes through your mind when you see any kind of object. You don't say, oh, that's a collection of matter. That's a collection of atoms, for example. No, a chair is what you're pointing to. That thing that's in front of you, that's a chair. And so if you want to teach your language to an extraterrestrial, Klingon comes to visit the planet, you don't say, well, a chair is a collection of matter, and a table is a collection of matter. An elephant is a collection of matter. No, you say that's a table, that's a chair, that's an elephant. That's how you do it. You point and you name. That's how it works. And so, what did you point to? Some kind of shape, something that's in front of them, okay? Some contrast there. And so, every object in the universe, whether 2D or 3D, has shape. It's a universal property. All objects have shape, right? If you can think of an object that doesn't have shape, I'd really like to hear about it, okay? So that is the scientific definition of the word object. We can use it consistently, but we can't use the other two consistently in any way, shape, or form. So those two definitions we throw away in the trash can. Okay? Those belong in ordinary speech. You can use them there, but don't bring them into science. They have no place in science, especially in physics. Okay, so how do we explain gravity? Well, again, we are going to make the invisible objects that Mother Nature uses to do gravity, we're going to make them visible so that you understand the mechanism. So you can imagine, visualize how Mother Nature is really doing this without you seeing, these mediators that she uses. She's bringing something down, and you don't see the things that are hooked onto the thing that's coming down. You just see the thing coming down, the visible one, but you don't see the invisible ones. And so we make them visible. And here it is. Here we have an astronaut coming down to Earth, okay? And we're making the objects that are bringing him down to Earth visible. And you see those lines there? And we're saying that every atom in his body, every single one, right? We're not, I didn't include all the lines that are connected to every atom in his body, to every atom on Earth. All we're saying is that every atom in his body is connected to every atom on Earth. And so the farther away the astronaut is, the less he weighs. Why? Because all these lines come together as a single coaxial. And as he approaches the Earth, they fan out. And so that's what we're showing there. That's what's bringing him down. That's the explanation for the acceleration of gravity. And that matches perfectly with Newton's famous equation, the one you see on the top. Weight is a static concept, so it's going to be location specific. Okay, and what we're saying is the number of independent ropes. Those are what those lines represent. Here you see the ropes. I've drawn the same thing a little, zoomed in with my telescope here, and there you see them. Okay, so what we're seeing is that the astronauts being connected to the Earth by all these ropes. As he approaches the Earth, the ropes fan out. Okay, and there is an acceleration because at every location closer to the Earth, there's more and more of these electromagnetic ropes, very thin, extremely thin ropes, intangible, invisible, right, that are getting farther and farther away from each other, and you see the fellow fall down towards the Earth. Okay, and this is more or less the mechanism here. Okay, if I can put it up here, give me a second here. There it is. Okay, so this is what's happening. When two objects are very, very far apart, the ropes superimpose and you have very little gravity. Okay, gravity is almost inexistent because all the ropes form a single coaxial, so to speak. But as one object approaches the other, the ropes fan out. That's what you're seeing also on the left with the astronaut falling to Earth. And that's what's causing the acceleration of gravity. Okay, so that is the explanation we give for gravity. Okay. And yeah, we do it with what we call the electromagnetic ropes. They are invisible and intangible. They have shape, but they are invisible and intangible. They don't have the property of being seen or touched by humans. Okay, and here is justification for that. Here you have again. I'd like to show Mr. Muller from Berkeley University, and he says every atom on Earth is pulling on every atom of you. You're also pulling on it. And the only way you can explain that statement, those two statements, is if something is connecting every atom. If you're not connected, then how do you explain what he just said there? You have no explanation for it. Okay, so if every atom on Earth is pulling on every atom of you and vice versa, right? Well, then it's very clear. Every atom is physically connected to every other atom. The only reason you don't see the atoms that are connected from the spoon to the Earth is because, they are invisible and intangible objects, because an object is not that which you can see or touch. An object is that which has shape. Okay, so this is the train of thought. This is how we explain it in this site. In general terms, you can see some of the other videos and see them in more detail.